Hello, Math 1050. This video is for section 1.4 and 1.5, which are both focused on quadratic equations, and there's a total of 8 topics. So our first topic is solving an equation written in factored form. So we've got 3 equations here we're going to solve. Primarily because I'm trying to show you 3 different scenarios that can come up. So the zero product property tells us that if 2 things multiply together and are equal to 0, that there are 2 potential answers. Either the first one is equal to 0 or the second one is equal to 0. So we'll use that to help us solve these equations. So we've got a factor of x plus 5 multiplied by a factor of x minus 7. That's equal to 0, so we can get one solution from each of those factors. Either x plus 5 equals 0 or x minus 7 equals 0. So to solve those, we get x equals negative 5. And for the other equation, we get x equals 7. And you can probably solve those in your head, just by looking at that first equation. So when you have 2 answers, just separate them with a comma. Don't put parentheses around it because that would be a point. This is just a list of 2 answers. So the 2 differences on this next problem are I've got another factor at front for x, and I also have a coefficient here of 10 with my x in that factor. And this factor also looks a little bit funny, so that's why I chose to do this one. So if you have 3 factors multiplying together equal to 0, then you have 3 solutions. So we get one solution from each of these factors. So either 4x equals 0, another solution is 10x plus 9 equals 0, and our third solution is 1 minus x equals 0. So to solve this first one, we would divide by 4, and we get x equals 0 because 0 divided by 4 is 0. For this next one, we would need to both subtract 9, and we also need to divide by 10. So we get x equals negative 9 tenths. And for this last one, I would probably think of it as adding x. You could subtract the 1, but then you'd have to also divide by negative 1. So if we think of it as adding the x, we get 1 equals x. So our list of solutions is 0, negative 9 tenths, and 1. The order that you type those solutions in does not matter. So if you put the 1 first, that would be okay. All right, so the last one right here, 2 times y plus 8 times negative y minus 5 equals 0. I wanted to point out that the reason that this 4x contributed an answer is because of that variable x. We had x showing up 1, 2, 3 times in that equation. But in this equation, y only shows up twice, one in the y plus 8 and one in the negative y minus 5. So we do just have 2 solutions. There is no solution associated with this 2 at the front. So our first equation, y plus 8 equals 0, gives us our first potential solution. So y equals negative 8. And then negative y minus 5 equals 0. I would go ahead and add the y here, and we get negative 5 is equal to y. So our 2 answers are negative 8 and negative 5. All right, one topic down. Our next topic is something called completing the square, and it's more like a little number game than anything else. So a perfect square is something like x plus 6 squared. So I'm going to write that down for a minute. Squaring means timesing a factor by itself. So if I think about what x plus 6 squared means, it means x times 6 plus x times 6, and if we distribute that and multiply it out, plus 36. We get x squared plus 12x plus 36. And maybe you're thinking to yourself, what does that have to do with this topic? Well, what we have is, in this goal, our topic is to find the mystery number at the end that would make each of these expressions a perfect square. So if our problem had said x squared plus 12x plus question mark, our mystery number is 36. So here's how you find the mystery number. We need the two factors to be the same. So this middle number needs to be twice as big as that constant at the end of each factor, because those are going to add together to give us that middle number. So if we take that number in the middle and divide it by 2, that's going to give us the constant in the factor. But to get the middle number, we have to square that. So that 6 squared would give us the 36. So let's apply that to these two examples. So I look at that middle number and I think about splitting that in half. So 4 divided by 2 gives me 2. And then I need to square to get my mystery number. And 2 squared is 4. So on this next example, I look at that middle coefficient and I think about half of that. So half of negative 14 is negative 7. And then I have to square to get my mystery number. And negative 7 squared is 49. So if we were to write these in factored form, which you don't have to do for your topic, but if we were, this would be x plus 2 squared, and this would be x minus 7 squared. And so that is the topic, completing the square. Okay, most of the remaining topics are going to involve the quadratic formula one way or the other. So you should be familiar with the quadratic formula from your prior math classes, hopefully. The quadratic formula can be used to solve any quadratic equation. Before you apply the quadratic formula, you do need to make sure your equation is written in standard form and equal to 0. So you don't want to have any constants over here. You need it to be in the form ax squared plus bx plus c equals 0. And if you do have your quadratic in that form, you can use those coefficients. X is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, Alex is special on this one. It does not have a plus or minus button, and it wants you to type in those two answers separately. So you have to think about, as you're simplifying it, you have to remember that you're going to have to type it in as these two separate answers, one with the plus and one with the minus. The biggest error that ever shows up in the quadratic formula, especially with students in 1050, is right here. If b is a negative, make sure you put that negative number in parentheses. It doesn't matter as much when it's positive. So let's do a couple of examples together. 4x squared minus 9x minus 1 equals 0. So for this topic, we have this nice equals 0 ready to go. So we can identify our coefficients. A is 4. B is negative 9, and C is negative 1. So x equals the opposite of b. Well, that would be a negative 9. So that's going to end up being a positive 9. Plus or minus. And if we're going to square that negative 9, we need to make sure that we get it in parentheses. Minus 4 times a times c, and it's all over 2 times a. So let's clean it up just a bit. We have 9 plus or minus something over 8. So I like to get my first term and my bottom number set, and then I can turn to my calculator and I can simplify my radical. Now, we'll do a topic in a second where we can get imaginary numbers. So make sure if you're typing this in to your calculator and you get an error, then you will have to, and I'll show you, you'll have to do it without the root. So I have my root typed in, and I'll let my calculator simplify it for me. And in this case, I can't simplify that any further. So in Alex, I would type it in as 9 plus root 97 over 8 and 9 minus root 97 over 8. Okay, our next equation is 2x squared plus 4x minus 1 equals 0. So on this one, we've got an a value of 2, b value of 4, c value of negative 1. So we've got negative 4 plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times our a value. So I'm going to leave the negative 4 in that first position, and we've got a 4 in our denominator, and I'm going to figure out my radical in the calculator. So we've got a 4 squared, and that 4 isn't negative, so I don't need to worry about my parentheses. It's when it's negative that I have to think about it. So we get 2 root 6. So the calculator has already simplified that radical for us. Now, this is an example of one where we need to do a little bit more simplifying. So our numerator has 2 parts, and our denominator is dividing both of those parts. So if you look at those 3 locations, the 2 parts in the top and the 1 part in the bottom, if you can reduce all of those by the same factor, you need to do it. So that negative 4 has a factor of 2, this has a factor of 2, and the 4 on the bottom has a factor of 2. So I can reduce all of those by a factor of 2. So this would be a 1 root 6, but we normally wouldn't write the 1 in front. And so that's my 2 answers. So when you're reducing with a radical, it reduces the coefficient. It does not reduce the number inside. You could think of it like having a 2x divided by 2. You know, the coefficient is what reduces, not the x. So think of that root like an x. The 6 under the root does not change when you're doing this reduction. If you were getting really confused about how to reduce that, you could type it in your calculator. The calculator often, and you'll have to just pick plus or minus when you do that, but I'll show you. So negative 4 plus 2 root 6 all over 4. So the calculator often shifts it around so you can see it put the root 6 first and then the minus 2 over 2, but you can see that matches what I have here. Of course, in Alex, we'll have to type those in separately as negative 2 plus root 6 over 2 and negative 2 minus root 6 all over 2. Okay, so now we're going to have some quadratics with complex roots. So we're going to end up with an I in these answers, and the topic itself is telling you that you're going to end up with those complex answers. So the method is not any different, just how we have to deal with that radical is different. So x is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. So our leading term there is a 5, and our denominator is a 12. So this is a case where if you just type in that radical, you're going to get a domain error. I'm going to do it just to show you. Minus 4 times 6 times 4. So if that happens, then you need to just do it without putting the radical in, at least at first. You need to figure out what that number is that's inside the radical. So we'll leave the radical off on the calculator, and we get a negative 71. And then if it's a radical that you aren't sure how to simplify, you can simplify the positive radical and then just include an I in your answer. And in this case, root 71 does not simplify. So we have 5 plus or minus I root 71 all over 12. And then for Alex, you'll of course have to type that in as your two separate answers with a comma separating them. All right, just one more of these. Our A is 2, our B is 6, and our C is 5. Negative 6 plus or minus our root. So our denominator is a 4. So this is looking like one that we're going to have to simplify because we've got a 6 and a 4, but we'll find out. So I'm not going to type my root in because I strongly suspect I'm going to get a negative number here. Probably you can multiply that in your head and find that out. Oh, we get a negative 4. So it's a negative 6 plus or minus the square root of negative 4. Well, we know the square root of negative 4 is 2i. So we have negative 6 plus or minus 2i over 4. Sorry, my 6's are never very good on my tablet. So we can reduce that. And remember, when you're reducing these, there's 3 parts, the 2 parts on the top and the 1 part in the denominator. And you have to reduce all 3 parts if you're going to reduce it. So they all reduce by a factor of 2. So we have negative 3 plus or minus I over 2. And so we can, of course, in Alex, we would need to separate that into 2 answers. You can type it like this, or you could break those into 2 separate fractions if you wanted. We talked about with complex numbers that you could. So if you separated it, it might look like negative 3 halves plus 1 half I, and with the negative as well. So if you want to type it that way, you can. All right. Okay, so this next topic has to do, so we're into the topics from 1.5 now, and we have 3 topics here. So the first one, using the Pythagorean theorem and a quadratic equation to find the lengths of the sides of a right triangle. So it's giving you a description of the triangle and asking you to calculate the sides. So here's my right triangle. It says the length of the longer leg of the right triangle is 4 centimeters more than twice the length of the short leg. So I'm going to call the shorter leg X, and the longer leg is twice the length of the shorter leg, but 4 more than that, so plus 4. The hypotenuse is 6 more than twice the length of the short leg. Our goal is to calculate the lengths of the triangles. Now, I scrolled through a million of these problems in Alex, and as far as I can tell, these are all factorable once you get them set up. So I don't think you'll have to use the quadratic formula on any of these. So the way that we're going to solve them is with the Pythagorean theorem, which you might recall is a squared plus b squared equals c squared, where c is the hypotenuse of the right triangle. So leg squared plus other leg squared is equal to the hypotenuse squared. Now, remember that powers do not distribute. We don't distribute powers. 2x plus 4 squared means 2x plus 4 times 2x plus 4. So write it out if you need to, or some of you can probably multiply that in your head. So we've got this x squared hanging out the front. This is going to give me 4x squared. I'm going to have 2 middle terms. I've got 8x and another 8x. And so that's a total of 16x. And then the last term is going to be a plus 16. Okay, on the other side of the equation, we need to multiply that out as well. 2x plus 6 times 2x plus 6. Sorry, my 6's are always so bad on this stupid tablet. So that's 4x squared. I've got two middle terms that I need to combine. 2x times 6 is 12x, and I've got another 12x for a total of 24x. And my final term is going to be a 36. So, let's see, I'm going to move this down. So in order to factor or use the quadratic formula, you need to have that equals 0 in your equation. So I'm going to start moving around some terms. Minus 36. Okay, so I've got my 0 over here now. Here are all my squared terms, and so these two actually ended up canceling out, so I've just got x squared. 16x minus 24, I'll do it wrong if I do it in my head, negative 8x. Oh, good handwriting, Bricky. Try that one again. Negative 8x. Ooh, still terrible. And then 16 minus 36, I believe, is negative 20. But I'm going to double check, because if I make a video and it's wrong, I will be crazy. Okay, so we've got to try to factor this thing. And hopefully you remember factoring. We start by looking at our leading term. That tells us that each of these factors is going to start with x. Then we shift our attention over to the 20. 20's got several combos. 2 times 10, 4 times 5, 1 times 20. I guess it's not that many combos. It looks like to get 8, we're going to use the 2 and the 10. To get a negative 8, we need the 10 to be negative and the 2 positive. So that gives us two possible x values, negative 2 and 10. Now the negative 2 in this context doesn't make sense. We can't have a side length on a triangle over there as negative 2. So we have the solution x equals 10. So x was that shorter leg, so the short leg is 10. 2 times 10. Oh, my tablet pen is not doing good today. 2 times 10 plus 4, they're parentheses, and they don't even look like it, is 24. For the longer leg, I wonder if my battery is dead. Or dying, I mean. And then for the hypotenuse, 2 times 10 plus 6. So that would be 26 for the hypotenuse. Okay, and as far as I could tell on these, they were all factorable. So look for factorizations once you get it set up. Okay, our next topic is applying the quadratic formula but getting decimal answers. Now, the reason that we know that they want a decimal answer here is because the topic instructions are literally going to tell you that. Round your answer to the nearest hundredth. Our other topics said that they wanted exact answers. Exact answers means we don't want to round anything. We want to leave it in that exact radical form. So for this topic, we want to get our decimal solutions and round them to the nearest hundredth. So you'll also notice that this is the first time that we don't have an equation starting with a 0. So we do have a first step of subtracting 3 from both sides. So our equation is 5x squared minus 7x minus 3 equals 0. So in the quadratic formula, don't forget to be careful squaring your b value. 4 times a times c. And that is all over 2a. If you're really brave and good with your calculator, you could try typing this whole thing into your calculator directly. I prefer to simplify it a little bit without typing the whole thing in, but I know some people like to just type it in. I'm going to type in the root on this one. If it's asking me for a decimal answer, it's not going to be imaginary. 4 times 5 times negative 3. So our root is root 109. And so in our calculator, to get those two decimal answers, we need to type that separately. So I would push the fraction button first so you can type in the numerator. So our first decimal answer, now your calculator wants to keep it in exact form. To get the decimal answer, you can use this button right here above enter. That is a converting button, so that's going to convert it into decimal form. So rounding to the nearest hundredth is 2 decimal places, so 1.74. And then I also need to ask my calculator to crunch the -1. Let's see, push the fraction button first, 7 minus root 109, and that is over 10. And again, it's going to try to keep it exact, so hitting that decimal button there. So this would be negative 0.34 if I round to the nearest hundredth. Then you would type those in separated by a comma. Okay, we have finally gotten to our last topic. This topic has several variations though, so I am going to do 2 of the variations with you. So we're going to do this one, asking us how long after the ball is thrown will it hit the ground, and it has a little diagram for us. And then we'll do this one where it's a ball being thrown, and we are trying to find the values for t for which the ball's height is 16 feet. I think these 2 variations will help you figure out any of the ones that come up. So we've got a height, let's see, the ball is thrown from a height of 40 meters, so it starts out at 40 meters. Initial downward velocity, 5 meters per second. The ball's height is h, and t is time in seconds. So it gives us the equation here and asks us how long after the ball is thrown does it hit the ground. So the first thing we need to talk about is hit the ground. If you've taken physics, you've probably done enough projectile motion to know what hit the ground means, but hit the ground means that it's at a height of 0. So we're going to put a 0 right there for h. 0 equals 40 minus 5t minus 5t squared. It does tell us to round our answer to the nearest hundredth, and we're going to use the quadratic formula. It's possible one of these would come up factorable, but I think most of them required the quadratic formula. So something here that sometimes throws people for a loop is they might accidentally say, okay, here's A, B, C, without noticing that that is not in standard form. So right now it has the constant first and the t squared term last. So I'm going to rewrite it in standard form. Negative 5t squared minus 5t plus 40 equals 0. And it may not be necessary for you to rewrite that. Maybe you can just pull the right coefficients without rewriting it. But rewrite it if it helps you. So our t value is going to be opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And this one's kind of awkward because both a and b are negative 5. So, if you're feeling fancy, you could type it in all at once. Maybe this time I'll do that to show you how that works. I'm going to literally type it the way it's shown. -5. You'll have to do the plus and the minus. Square root of -5 squared minus 4ac all over. I am just going to type a -10 there. Just do that little multiplication in my head. Okay, so this gives us one of our answers. It's giving it to me in radical form, so I'm going to hit that conversion button. -3.37 if I round to the nearest hundredth. Now, in the context of this problem, that doesn't even make sense. -3 seconds, it's like the ghost phantom of when the parabola would have, been at 0 height, like before it got thrown. But it doesn't make any sense for our problem. So we need to get that other answer. So if you're good at converting or using your calculator, you could just input, or you can go up and select the line and scroll back and change it to a minus. If you're not good at that, just retype it. But some people are really good at editing in their calculator. So our second answer, which is the one that makes sense in the context of the problem, is 2.37 seconds. And that's what we would type in for our answer. Okay, so the other variation of this that you might see is something like this. A ball is thrown from an initial height of 3 feet. So this was 3 feet high. Initial upward velocity of 30 feet per second. The ball's height after t seconds is given by this lovely equation. We need to find all t values for which the ball's height is 16 feet. So we're still putting in our height right there, but this time our height is 16. I circled it and it looks like I wrote a 0, but our height for this problem is 16. So 16 is equal to 3 plus 30t minus 16t squared. So we could subtract the 16 here if we want, but noticing that my equation is not in standard form, I think I'm actually just going to move these terms over to this left side. So minus the 3 and minus the 30t. So that kind of looks not very clean, but 16t squared minus 30t, and our constant is 16 minus 3, so that's 13. And now it's equal to 0 because I moved everything over to the right. So for our t value, we'll use the quadratic formula. Minus 4 times a times c. The quadratic formula is on the formula sheet for Math 1050. So you won't have to have that memorized. It is on the formula sheet. Okay, so let's put that in our calculator. 30, let's see, fraction button, 30 plus the square root. And you can crunch that in your calculator. Okay, so our first answer in decimal form is 1.195. So if I'm rounding to the nearest hundredth, that would be 1.20 seconds. Oh, good handwriting. And then our other answer, I would not try to edit this version. I would go back to your input, scroll up, hit enter, and you can scroll back if you want to do it by editing. If you try to edit the one that the calculator simplified, you will probably oftentimes get a sign wrong or change the wrong sign because it moves, it changes the terms and stuff. So I like to go back to my input. Okay, and then the other answer is 0.67 9. So that's going to be 0.68. Wow, it does not like it when I write words. Sorry, 0.68. All right, so those are our two answers. In this case, both answers make sense. You're throwing, 3 foot high, you're throwing a ball. It hits that height of 16 feet on the way up and then again on the way down. So that's the reason we have two answers that make sense here, is because we're throwing it up. So it does hit that height twice. All right, so we have made it through quadratics. If you're having issues with your Alex topics, you can email me. These ones aren't due for a while, so we should have time to get any issues squared away. Thank you.